A typical quadratic equation is normally given as ax squared plus bx plus c equals 0. Using the AC method, what we want to do is multiply a by c, and that's where it gets the name AC method from. So our first step, step 1, a times c. For our second step, we want to find factors of AC that when added is equal to b. And for our third step, we factorize and solve for x. And this is all we need to do to solve a quadratic equation. So now let's take a look at an example. If you are given this equation, x squared minus 7x plus 12, and it's equal to 0. As we said before, first step, we multiply our a by our c. Here we can see that our a is equal to 1 and our c is equal to 12. So that means our AC is equal to 12. 1 times 12 is 12. Now we want to find factors of 12 that when added is equal to negative 7. So let's write factors of positive 12 because we have to pay attention to the signs. So factors of positive 12 would be 1 times 12, negative 1 times negative 12, negative 3 times negative 4, negative 2 times negative 6, and the positives of these. So we want a number that when we add them, we get negative 7, but when we multiply them, we get a positive 12. And we can see that if we add 1 and 12, would get 13. So this can't be it. If we add negative 1 and negative 12, would get negative 13. So this again can't be it. Now, if we add negative 3 and negative 4, would get negative 7. So this here would be our two factors, negative 3 and negative 4. Now we're going to put these in the equation for 7x. So let's do that. So we would have our x squared minus 3x minus 4x, and our c was plus 12. That's equal to 0. Now we want to put these in two separate brackets. So we're going to have x squared minus 3x, and then on this side minus 4x plus, or I should have minus 12 equals 0. Now for the first bracket here, we see that x is common. So from the last video we know how to factor. So when we factor out the x, we would be left with x times x minus 3. And this side, the 12 can be divided by 4. So 4 is a factor of 12, so we can factor out the 4 because 4 is common between the 12 and the 4x. So we would have 4 on the outside and x minus 3 on the inside. These are equal to 0. Now we see that in both brackets we have the same term. So we're going to have this bracket being multiplied by x minus 4. From the last video, we know that when multiplying and it's equal to 0, then either this is equal to 0 or this is equal to 0. So we're going to equate both to 0. When we transpose this one, x is equal to 4. And when we transpose this one, x is equal to positive 3. So the answer for our quadratic equation would be x equal 4 and x equal 3. And that's using the AC method. For our next example, we have 8x squared minus 6x plus 1, and that's equal to 0. Remember, the first step is to multiply a by c. So ac would be equal to 8 in this case, because 8 times 1 is equal to 8. Now we want to find factors of 8 that when we add them, we get negative 6. So let's write them some factors of 8. So factors of 8 include 1 and 8, 2 and 4, negative 2 and negative 4, negative 1 and negative 8 to get a positive 8. For our first factor, if we add this, remember we're trying to get this negative 6. If we add 1 and 8, we'd get 9. So this is not it. If we add 2 and 4, we would get a 6, but not a negative 6. So this is not it. But if we add these, negative 4 and negative 2, we would get a negative 6. So this is our two factors. So let's put those in our equation. So all we did, we used these factors to replace the negative 6. Our next step is to put these in parentheses by themselves and these in their own parentheses. So let's do that. Now we see that this negative sign is changed. I realize I never addressed it in the first example, but the reason why the negative sign, the positive sign here is changed to negative here is because we're negating everything inside this parentheses. So when we negate this negative 1, it will become positive 1. So don't let that confuse you. Now, as we did before, we factored both parentheses. So when we factor this first one here, we're going to take out what is common. And remember, we're taking out the highest common factor, not just any factor. So here we can see that 2x is common in both because 2x can go inside 8x squared, right? So we're going to factor out 2x. On this side, what is common? The only thing is common here is 1 because 1 can go in any number. So we're going to factor out 1. And this is equal to 0. Again, we see that our parentheses are equal. So we're going to write the 4x minus 1 as its own parentheses. And then 2x minus 1. And we're going to equate them to 0. For our next step, we're multiplying again, and it's equal to 0. So that simply means that either this side is 0 or this side is 0. So we're going to equate both to the 0 separately. So when we solve for x in this equation, we'd have, firstly, we'd have the 4x equal 1. And we're going to divide both sides by 4 now so that we can have x on one side. So x is equal to 1 over 4. For this equation, we're going to do the same thing. So we'll have x equal 1 over 2. doing the same transposition as before. So the answers for this quadratic equation would be x equal a quarter, or 0.25, and x equal a half, or 0.5. Now I promised that I would look at the quadratic formula as well as completing the square. So the next thing we're going to look at is the quadratic formula. Using the same example, 8x squared minus 6x plus 1, and that's equal to 0. That's the example that we just did. So the quadratic equation is this. X is equal to b plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic equation. So what we're going to do is plug in our coefficients. Remember that this here would be a. Even though these are common letters, the 8 would be the a in this case, the 6 would be the b, and the 1 would be the c. So let's plug those in our formula. By the way, this should be a minus b. So let's plug in our values. So first thing, our negative b. So negative 6 would be positive 6. So we'd have 6 plus or minus the square root of negative 6 squared minus 4 times 8 times 1, where 8 is our a and 1 is our c. All of this is over 2 times a, which is 8. Now, depending on what calculator you have, or if you are allowed to use calculator, you can do a direct plug-in and get your x right here. But if for some reason you have to show working straight down, let me show you how you do that. If you have to show working, this is how you do it. You are going to write back the 6 as is, plus or minus the square root of 36, because negative 6 squared would be 36. It's negative 6 times negative 6. Minus 4 times 8, which is 32, times 1. So this would be 32 still. All of this is over 16, which is 2 times 8. Next, we want to subtract what is under the square root. So we'd have 6 plus or minus the square root of 36 minus 32, which would be 4. All of that is over 16. So now that we're at this stage, we find the square root of 4, which is 2. So let's do that. And this is where we get both the x values. 1x would be equal to 6 plus 2 over 16, which would be equal to 8 over 16. If we reduce this, we will get a half. As before, remember we got a half for one of the x values. Now for our next x, when we subtract, we'd have 6 minus 2 over 16, which would be equal to 4 over 16. When we simplify 4 over 16, we have 1 over 4. As before, we got a quarter and a half for our x values. And this is how you use the quadratic formula. You just identify your a, your b, and your c. and you plug them into this equation here, into that equation. Now for completing the square, I'm going to do just one example as I did with the quadratic formula. And by the way, the quadratic formula was derived from the principle of completing the square. Or that is one way you can derive it. Say you add this example, x squared minus 2x minus 2, and this is equal to 0. If you attempt this using the AC method, where we multiply the a by the c, our AC would be equal to negative 2. Now, the factors of negative 2 would be negative 1 times 2, or negative 2 times 1. This should be a 1. Now, if I should use these two factors, and add them, I'd get 1. And 1 is not equal to b. If I use these two and add them, I would get negative 1. Still not equal to 2. So, and these are the only factors of our AC. So we simply can't use the AC method here. We could use the quadratic formula, but I'm going to use this example to show you how you would do this using completing the square. So completing the square is a list of steps as well. So the first thing you want to do in completing the square is identifying A and B and C. So once you identify these, after you want to find half of B, so you're going to divide and try to make A 1 always. That's one thing you want to do. So if A is a number greater than 1, you want to divide by that number, show the entire equation before you apply what I'm going to do here. So remember, you need to make a 1 for this to work. So you're going to divide b by 2, or find half of b and then square that value you get, and you're going to add that value and subtract that value at the same time. So let me show you how I do that. In our example, x squared minus 2x minus 2 equals 0, or b would be negative 2. So we want to find half of negative 2 and square it. Half of negative 2 would be negative 1. When we square negative 1, we get a positive 1. So we are going to add and subtract that positive 1. So we're going to have x squared minus 2x plus that 1 minus the same one minus 2, and that's equal to 0. And this is the part that we add in. So now that we have this, we're going to use this side. We're going to use this side to do our normal quadratic equation using AC method, and we're going to simplify this side. So let's do that. So this would now be our C. A is here, which is 1. So 1 times 1 would be 1. So AC would be 1. Now, the only factors of 1 is 1 and 1, and negative 1 and negative 1. We can see right off the bat that these are the two factors that will be added to be equal to negative 2. So this is what we're going to replace the negative 2 with. So let's do that. So x squared minus 1x minus 1x plus 1, and this negative 1 and this negative 2 here would now be negative 3. So let's put but these in parentheses so we can see what we're working with. Now, as in the AC method, we're going to put these in parentheses by themselves and these in parentheses by themselves. So let's do that. Now we want to factor, so let's do that. When we look at the first parentheses, we realize that x is common, so we are going to factor out the x. So we have x, and x squared divided by x would have x minus 1 for our first term. For our second term, we'd have 1 on the outside, which is the thing that is common between both, 1, and we have x minus 1 on the inside minus 3. And remember, this is equal to 0. Now we can see, again, as in the AC method, that x minus 1 is common. So we're going to have x minus 1 times x minus 1, and I mean this x minus 1. So scroll up, we have x minus 1, which would be these. Then for these, x minus 1. And then we have a minus 3 equals 0. At this stage, we have a perfect square, so we can rewrite it as x minus 1 all squared minus 3, and that's equal to 0. Next, we want to take the 3 to the other side. So this would be x minus 1 all squared equals positive 3. Since this is being squared, we want to find the square root of that so we can find our x. So we're going to find the square root of both sides. When we take the square root on both sides, we have x minus 1 equals the square root of 3. But now, since we're finding the square root, we're going to have two values, a plus and a minus. And this is from the principle that if you have 2 and you square it, you get 4. And if you have negative 2 and you square it, you would still get a 4, a positive 4. So that is the reason we're going to put a plus and minus here. Now that we have the x minus 1 on this side and a plus minus the square root of 3 on this side, we want to take this one on the other side. When we take this to the other side, it will be positive 1. So x is equal to 1. We're taking this negative 1 on the other side, so it becomes positive 1 plus or minus the square root of 3. Now that we have plus or minus the square root of 3, we're going to have two values for x. X equal 1 plus the square root of 3, and x equal 1 minus the square root of 3. And this is how you solve by using completing squares. I'm going to do individual videos because I need to explain in more details so that you can understand. And this is it for this video. Thank you for watching.